The next demo we're going to focus on is really all about saving and exporting the packets you've captured. Of course, if you've gone to the trouble to capture packets, chances are you're going to want to save them. And even if you're only doing a temporary analysis, you won't necessarily need the packets, tomorrow or the next day. It's still a good idea once you've captured those packets to save them, because you never know what could happen. You could have to reboot your computer. You could experience a crash. Maybe Wireshark has an error and crashes for some reason. And certainly, if you're trying to capture a specific event, or if you've had to emit some type of stimulus to create a specific response you wanted to capture, you don't want to have to redo that work. So saving packet captures is important. Now, you might say, well, Chris, saving packet captures is pretty trivial, right? It's just like saving a Word document or an Excel document or anything else. You just file save and you save it. And you'd be right. That is absolutely right. Matter of fact, we'll go ahead and do that now. In this case, I've captured some packets. I'm just going to go ahead and stop those, and I'll click File. We'll do Save As. And I'll just save this file to the desktop as demo. We'll just call it demo.pcapng and click save. And sure enough, if we go look on our desktop, the file is there. So pretty straightforward. It's what you would expect. But Wireshark provides a lot of other features that are really useful for saving packet captures, either in an automated way or in a way that allows you to strip down the packet capture so that you're only seeing the things you want to see in that saved file. So these are skills you'll want to be able to have, especially when it comes to a scenario where you're capturing a ton of packets and you want to narrow down and maybe save fragments of that packet capture out as additional packets. There's a lot of great ways to do that as well. So let's actually go through some of those techniques. So as an initial scenario, let's say that instead of capturing some packets and then saving them off afterwards, let's say we want to automatically save the packets we're capturing. This is a really great idea if you're going to be doing a long-term packet capture and you don't want to babysit, or if you have some specific criteria or thresholds you want to be met. Certainly in one of the last demos we did, we showed you the capture options dialog and how it had a few different options you can use there. So that's actually what we're going to go in and explore now. So if I click capture and then go to options, and then I go to this output section, we see some interesting things. We have an option here to capture to a permanent file. And basically what this says is if I specify a file name or a location, when I click start and make my capture, whatever packets are captured will automatically be saved to that file. So once I've captured the packets, they're ready to go. So matter of fact, let's go ahead and do this. I have a location already in here on my desktop, a demo file. We'll go ahead and name that demo.pcapng. And I'll go ahead and just click start. So we're going to capture a couple packets here, and then I'll click stop. And you'll see already at the top of the screen it says demo.pcapng. So if I go and look on my desktop, we have demo.pcapng, and that's the file that I just created. And it did that automatically, so I don't have to save things. So if you want to make sure you're not going to forget to save something, this is a really good way to do that. So I'm going to go ahead and close this file, and I'm actually going to go a little bit farther here. So I'm going to go back to capture options and to output. Now, let's say that we wanted to capture to a file, but we wanted to create segmented files. And let's say we wanted to create a new file automatically after every 2 seconds. That seems reasonable, right? Say we want to, there's a certain event occurring, it happens every 2 seconds. Maybe it's a piece of malware phoning home, maybe it's an application doing some type of heartbeat, and we want to capture things in segments and break up those packet capture files. So we want 2 seconds of data. You could also do this by byte size, which is really common. Let's say I know I'm capturing a lot of data, but I don't want to store it all in one gigantic file. So I could do 1 megabyte files or 10 megabyte files or something like that. So you can create a new file automatically after these time periods elapse. Now, we're not going to leave it just at that. The thing is, if I tell it to do this and say create a new file every 2 seconds, and I walk away and leave this thing running for all night, it's going to create a massive amount of files, way too many files that I'm going to want to deal with. So I'm going to go over here to the Options tab and tell it to stop the capture automatically after, and we'll say 5 files. So we have this section here where we can tell it where to stop. It's a little odd that these are on two different tabs. They kind of might make sense to go together, but nonetheless, you can use them together, and that's what I'm generally going to do when I'm doing these things. Is pretty much anytime you go here and tell it to create a new file after a certain thing is occurring, you always want to go to the Options tab and tell it how many max files to have, or else you run into a situation where you just may create thousands or tens of thousand files, or you may do something weird like fill up your hard drive. You never know what's going to happen sometimes when you let this thing go and just start capturing packets. It could get unwieldy quick. So let's go ahead and do this. I've got my option set to create a new file every 2 seconds, and I set a max of 5 files. So I'm going to go ahead and click Start. And you'll notice we're capturing files here, and then the file is closing, and it's opening up a new file. It's going to do this 5 times. So we're done. So we've got 5 different files here. You can see at the top it gave it a name of demo 00005 and then a timestamp. And that's how Wireshark is automatically going to name these. Obviously, each file can't have the same name. So if I go look on my desktop, sure enough, we have demo 1 through 5. These are the 5 files we told it to create. And if you look at the timestamps on the end of the files here, we see every 2 seconds. So it ends with 22, 24, 26, 28, and 30. So we have that precision in there, and we have that timestamp to reference it by, so we know exactly where and when the capture was taken. Now, Wireshark also lets you, it gives you a utility that allows you to view this set of files. It refers to this as a file set. And if you click on the file menu item and go to file set, you can actually say list files. And it will show you all of the files in this set it's captured. And Wireshark does this just to provide an interface so you can quickly see what you're dealing with and pivot between these things. So I can actually click on one of these and move in between them. Just a single click will move in between each file, which is a pretty neat thing. And you can also go here to file set and do next file or previous file in this list. So if you do have a set of files like this you've captured, you can use file sets to very quickly pivot through those and compare and contrast between them, which is a lot easier than just opening up 10 different Wireshark windows and trying to fit them all into the screen at once. That doesn't really work most of the time. But using this technique is a really neat way to set up some automated capture and capture a specific event divided across multiple files. I don't normally use this with time intervals specifically a lot myself, but I do it a lot with disk intervals. So with file size intervals here. So if I go to the output tab, you see file size. I'll often specify, collect a file, but break it up every, 20 megabytes. The thing is, the larger your file size, the longer it takes Wireshark to open the file or perform analytical tasks on the file, create graphs, create statistics, things like that. And we'll encounter a little bit of that as we go through the course and get into some of those more advanced features. But you generally want to keep your files manageable. You're, of course, loading those into memory, and the more you load into memory, the slower things are going to be. And memory is a finite resource, so you have to be careful about how much of it you use. So there's no real hard and fast rule about how big your file should be. You'll kind of have to play it by ear. I can say you don't want to be creating, gigabyte-sized files. Those can get really unwieldy fast, and when you get into the files that size, you're going to spend more time probably opening them up in T-Shark or TCP dump on the command line, and then extracting things you want from them to open in Wireshark rather than opening it up in Wireshark itself. So you have to be a little cognizant of that as you're making these decisions. The next option I want to explore here is the ability to save files in a ring buffer. Now, if you've not used a ring buffer before, consider the fact that basically it means we're going to have a specific number of files. In this case, we'll say 5 files. And then we have a threshold that we're using for creating new files. So let's say, looking at this screen here, we have the option to create a new file automatically after certain things occurred. We'll say we're going to do one every 5 seconds. So every 5 seconds. And then we're going to tell it we want to use a ring buffer, and we want to create 3 files. So what that is saying is a ring buffer is saying, a ring's a circle. So when we get to the end, the next place we go to is back to the beginning. So in this case, Wireshark would save a file every 5 seconds. It would create one file, move to the second file. After 5 seconds, it would finish, create a third file. And then after 5 seconds, instead of just stopping or creating a fourth file, it's going to go back to creating to that first file. And it's going to wipe out that first file and create a new one with another 5 seconds of data. So the thing is, we should never have any more than 3 files and Wireshark will just continue to move through those files, rewriting each one over and over again, really to the end of time. For the most part, if you don't specify any limiting factor. Of course, over here we could go here and limit it to a certain number of packets or minutes, but for the most part, the ring buffer will keep going until you manually stop it. It's not really the best option for just capturing to a specific set point, but if you know you need to capture something and you want to limit the number of files and maybe limit by size or by time, you can do that. So limiting by size is something that really makes sense here. So saying, I want no more than 300 megabyte files. So that way, you'll never have more than 300 megabytes of storage taken up on disk. And if you've only got a little bit of disk space you can work with for this type of thing, this is a way to make sure you're not going to go over that. So that's one thing that works. For the purpose of the demo, because it's a little faster, I'm going to do it time-based, and I'm going to go with this demo that says we're only going to have a ring buffer of 3 files, and we want to do this every 5 seconds. So I'm going to give this a different name. I'm going to call this ring.pcapng. And we're going to start that. And I'm going to go ahead and pull up my screen here. And so you see we've already got ring 0001 created. Now we have 2 created, and we'll wait just a couple seconds. And then we'll have 3 created. And you know what? We're not going to get a 4. Instead, we see the packet capture refresh. And we get we're going back to the original file. Now the thing to note here is we did get a 4 in the sense that we got a file named that. The files are getting renamed, so you can get some sense of order. So the 5th file edited is actually going to be named 05. So we are creating a new file, getting rid of the old file. That's actually happening here to keep a sense of order in those files. So you see we're up to 7, 8, 9 now, 8, 9, 10. And every 5 seconds, this is just going to keep incrementing basically to the end of time or until somebody stops this thing. So I'll go ahead here and stop it. And if I go back and look at my file set, my list of files, you'll see we have these 3 files that were created. We see their sizes here. We see they're created and their modified times. And we see that those are in 5-second intervals. So we have here 10:20:03 to 10:20:08, 10:20:08 to 10:20:13, 10:20:13 to 10:20:13 where I stopped it. So this is creating our ring buffer. I don't find myself using ring buffers often, but again, if you have a finite set of data to work with, disk space to work with, then a ring buffer is a really good way to specify that you're going to get these files broken up into the increments you want them in, while only taking up a very specific amount of disk space. So there may be some cases where you find that a ring buffer is a good option for you when you want to automatically save your capture files kind of in an unattended way. So thus far, we've talked about cases where you have just captured some packets and you want to save all of them, or you want to proactively save a packet capture file from the packets you're going to capture. And those are both very common scenarios. But another common scenario is one where you say, okay, I have a bunch of packets that I've already captured. Maybe they're already saved into a larger file. Now I want to take a subset of those packets and save them out into different files. And we're going to enable that by a feature called exporting packets. And Wireshark calls it exporting, but you can think about it as selective saving. So in this case, we're going to still do a save as basically, but we're going to be selective in what we're actually going to save. And we have a few different options that are available for us to do that. Now in this case, I've opened up a file called http ESP fail, which is a file we'll work through much later. But I've opened it up because it has a lot of different things going on and a lot of different conversations, a lot of things we can work through. So let's say in this case that I didn't want all of this traffic. I wanted to save off some of it for more focused analysis. And that's a common technique. There's a lot of packets in this file. You see down here at the bottom, there are 569 packets. So it might stand to reason that we want to filter things out by a specific conversation or by a specific protocol and analyze those independently. So let's say in this case, I'm only interested in the DNS packets, the DNS traffic here. You see we have the protocol column, and there's some of them that are identified as DNS. Now we'll talk about filtering much more later, but just suffice to know that I can apply a filter where I'm simply just typing the protocol name, which is DNS, typing that up here into this filter bar, and it's going to show me only DNS traffic. All the other packets are still there. So if I click the X right here, that's a little small and hard to see, it's going to clear that filter, and you see everything else is still there. I'm just hiding the other packets by only showing the things that match the filter I'm applying. So in this case, let's say I want to save off all of this DNS traffic and only this DNS traffic. You might think I could just go to File and Save As, but I don't really have a lot of options here. There just isn't an option to save just the filtered data. And if I hit File Save and I give this a name and save this, all the data is going to be there, not just the data that I've limited with my filter. So instead, I'm going to hit File, Export Specified Packets. Remember, I said export is kind of like save only a subset. So if I hit Export Specified Packets, you'll see I've got quite a few more options down here at the bottom, and a lot of these are going to be really, really useful to us. So one thing you see immediately is I have two kind of columns here. I have captured and displayed, and they have numbers. So if I click on captured, it's going to say 569 packets. So if I were to give this a file name right now, it's called export, and hit save, it's going to save all 569 of those packets. So it's essentially going to create a copy of what I'm already looking at. I'm going to name this export 1, and instead I'm going to actually hit displayed. And if I hit displayed, it's going to show me that there are only 14 packets displayed. Those are the 14 DNS packets. So if I hit save now, I'm actually going to save just those 14 packets that are displayed via the filter I've applied. And I'm going to go ahead and do that. And we'll open that back up. Now in this case, notice there's no display filter applied here. And yet I still only have 14 packets. So in this case, I've only exported the things that match the filter. And this is probably one of the most common things you'll be doing in Wireshark when you take a capture or take a packet capture file and want to segment it out, is applying a filter and then exporting just the things that match that filter into a separate file for dedicated analysis. So I'm going to go ahead and open back up the same file I just had open, the HTTP ESPN fail file located in this packets folder. So we've got that back open. We've got our capture that has 569 packets in it. So we have a couple other ways we can identify packets we want to selectively export. Of course, I said the most common is going to be to use a display filter, but you can also individually mark packets. So let's say I'm only interested in the first, I don't know, let's say 5 packets in this capture. If I right click one of these packets, the first option I have here is mark or unmark packet. So if I click that, you notice it changes the color of the packet. It changes it to a black background with white text. And that indicates the packet is marked. So I can actually do that with all 5 of these first packets. Now there's a lot of reasons you might want to mark a packet. It's a very distinctive color scheme within the other colors we see here. So it's just a way to visually discern that that packet might be special or might be of interest. Perhaps it's a packet that you saw that had a high amount of latency between it and the previous packet. Maybe it's something containing a malicious GET request, something malware related like that. Any number of reasons you might mark packets. I might mark packets all the time. But in this case, the reason I'm marking these is I want to export just these 5 packets. So I mark those and go to File, Export Specified Packets. You'll see under the displayed and captured areas both, I can actually go check this box or select this bubble that says marked packets, and there are 5 here. Now in this case, there are 5 packets marked and they're all displayed and captured. So captured display doesn't really matter. It's the same 5 packets. And I can go ahead and save that as a different file. We'll call this export 2. And I'll go ahead and click save on that. Now it's important to note the ability to mark packets is a toggle. So I can actually right click here and click this same option again and it'll unmark the packet. You can also use Control M as the keyboard shortcut for that. That's the easiest way to do that. You'll see here I've unmarked the first one. I'm going to go ahead and unmark the second one, unmark this one, so on and so forth. So there are a few different options as far as marking packets there. The thing I really recommend is only marking packets on a very small scale. So don't select 200 packets and mark those. and then try to export them that way. That's very time consuming. It's honestly not the best way to do it. If chances are, if you need to mark 200 packets and export those, you're probably better off writing a display filter that would match those and doing that via filters and then exporting that rather than just doing it the way of marking all those. Just a time consuming thing. So that said, I can go ahead and open export to.pkapng. And you'll see that we have just the five packets we specified. They're not marked here. That the marking isn't necessarily saved with the file. That's just a feature of Wireshark. So if I mark a file, mark a couple packets in a file, close that file, and then reopen it, those packets will no longer be marked. So that doesn't save with the file, and you'll see that reflected here within these 5 packets that we've captured. So marking is another good way to effectively export packets that may be a subset of a broader packet capture you're working with. Now there are a couple other options you can take advantage of when you mark packets and you want to export those. And you may have seen those already when I've showed you the export options. But let's try this. Let's say I want packets 1 through 10. Again, we've already done that in a couple ways. But say I want packets 1 through 10. I'm going to mark the first packet number 1 here. I'm going to go down and mark the 10th packet. So we have 1 and 10 marked here. Now what I can do is go to File, Export Specified Packets, and I have this option for first to last marked. And you'll see here the number is 10, so that's 10 packets, 1 through 10. So this gives us a way, if you do need to select a large swath of packets that are at least in order or at least in sequence, you can do the same thing with marking, but instead of marking all those, you just mark the first and last one. And so I can go ahead and name that Export 3. Save that out. And sure enough, we have 10 packets here. So that's the start to the end of the marked packets. So there is one last primary export option I want to show you, which is a little relevant to some of the things we'll be doing here. And I talked about the ability to save off ranges. And really, again, you're going to be using filtering, or you can use marking, but you can also actually just specify a range. So if I go to File, Export Specified Packets, I can go down here to Range and just tell it I want packets 1 through 10 and do it that way. And you'll see it shows me that that would be 10 packets. Of course, if I change that to 11, it's 11, 12, it's 12, and so on. So I'm going to tell it I just want these first 10. We'll call this Export 4. Save that out. And of course, we have just the 10 packets we specified. So we have a lot of different means to get to the ends we're looking for, and they're all very effective ways of filtering down. Again, packet capture or display filters, will be the primary means of doing more complex filtering and exporting. But the thing to keep in mind here is that an export is just the ability to save with some more specific options, so that you can save out a subset of the packets you're interested in, kind of stripping those or carving those away from the primary file that you're analyzing. So I have one final export option I want to show you, and then we'll lay this exercise of saving and exporting packets to bed. But this is an important one, especially I find for folks who are doing who want to do some parsing on the command line. Maybe they're doing some application development, something of that nature. But sometimes you need to get packets out of Wireshark in a format that's digestible by something that doesn't necessarily read PCAP files. So something a little simpler, perhaps a Unix command line tool, your greps and seds and awks and things like that. Those tools aren't going to be able to read the packet capture too easily, and you might want to output that data in a more an easier to access way, and that's going to be a CSV file, a comma separated value file, which conveniently enough can also be imported into Excel. So if you want to do some graphical manipulation with Excel, that's a great way to do it. I once had a colleague tell me that really any person who's trying to develop a security solution like a SIM, or trying to develop some type of data manipulation tool, is essentially just trying to recreate features of Excel, because eventually we all end up back in Excel doing the things it offers us. And there's no shame in that. I've done plenty of exporting packets to Excel myself in order to do some string parsing and searching and things like that. And again, no shame in that at all. It's whatever really is the best tool for the job. Now in this case, let's say I want to take these packets and I want to export a series of them to to CSV format so I can open them up in another tool. In this case, let's say I want to do, let's do the DNS packets. So I'll filter this down to DNS. I'm going to go to File, and instead of going to Export Specified Packets, I'm going to go one notch below it and say Export Packet Dissections. And here you see we have a few different options. We can actually take these packets and export them as plain text, CSV, which is what we're going to do in a minute, C arrays, XML, or JSON. So if you're writing an application that needs to be able to parse packet data in JSON or XML, this is a great way to get that data. Or if you just want to do what we're doing and send it to plain text or CSV, that works as well. So I'm going to go ahead and click this CSV option here. And you have to be careful because you have the same stuff you're used to, but there are a couple other options here that Wireshark by default is going to kind of cut off a little bit. So I'm going to go ahead and expand this out to show those things, because these options over here tell us the format of the data that we have available to us. So in this case, we're going to leave it mostly default. We want to print the packet summary line. We want to include the column headings. We want the packet details as they are displayed, although we have the option of saying that they could be all collapsed or all expanded. In this case, let's go ahead and tell it we don't want the packet byte. That's going to be pretty noisy. And we can tell it that we want each packet on a new page, but that's a lot of, we don't want that. So I'm going to go ahead and tell it to put this on our desktop. We're going to call it export 4. And we're going to tell it we only want the displayed packets, which are 14 DNS packets. So I'm going to go ahead and click Save here. And we have export 4, not export 4.pcapng. That's a different thing. This is export 4 as a file. And we're just going to go ahead and open this up in Notepad. And we have our CSV file. So we see we have the column headings here, number, time, source, destination, protocol, length, and info. And if we stack this up against what we have here, we see we're looking at the same thing, right? So it's the same timestamp. Here we see packet 1. I'm going to highlight packet 1 for you, and you see it's the same value as packet 1 here. So we have columns for everything we would expect. Here are our IP addresses, DNS. Here's our packet info data, and this is now in a CSV format. We can dump into something like Excel or use Linux command line tools or Windows command line tools for that matter to parse it. So this is just another way to export data. Wireshark is really great about having a lot of flexible options for data export, and the ability to export in CSV is one of them. So that's going to bring us to the end of this section on saving and exporting packet capture files from Wireshark.